Okay, number 57. All right, so number 57, we are just asked to find a limit if it exists. So we see that this isn't really a problem of, well, we can't do direct substitution because it's outside the domain of the function, because if we directly substitute in 0, we get division by 0. So in the numerator, we see that we have some radicals. We realize also that this isn't really a problem of factoring. So it's probably a problem where we have to rationalize the numerator into the denominator so that we can put it into a different form and see if we get any cancellations after we rationalize. So we have square root of x plus 5 minus the square root of 5 in the numerator. So we'll multiply by its conjugate, which means that we just take the opposite sign so that we create a difference of perfect squares. So we're going to get the quantity of square root of x plus 5 squared minus the quantity of square root of 5 squared in the numerator. And then we have this leftover term because we have to multiply the top and the bottom by the same amount of square root of x plus 5 plus square root of 5. Okay, so then this brings us to here. Notice also that if we're taking the limit of as x goes to 0, we should carry that forward, right? Because all we're doing is changing the form of this. And if we write down that we're taking the limit as x goes to 0 and suddenly we don't write the limit as x goes to 0, someone might think that we've already substituted it in. Or you might lose track of it or something like that. So you should really carry that forward, at least as a bookkeeping mechanism or just to be thorough. So here we are at this step, and when we square both of these, we get rid of these radicals. So we are left with x plus 5 minus 5 divided by the quantity of x times, bringing the denominator down exactly as it appears. Then we get some cancellations, right? We have our plus 5 and minus 5. They cancel out in terms of addition. And then all that we're left with is one factor on the top of x, and we also have one factor of x on the bottom here. They cancel, leaving 1 in the numerator. So then now we no longer have this factor of x here, so we can do direct substitution. And we won't get division by 0. So when we directly substitute 0 in for everywhere that it occurs in the function, we get 1 over square root of 0 plus 5 plus square root of 5, which is equal to 1 over 2 times the square root of 5. And that is what the limit is equal to. So that's number 57. How about number 59? Let's see. We have in number 59 1 over 3 plus x minus 1 over 3, and all of that over x. One thing that we can do right here is recognize that we have division and we have fractions in the numerator. Normally we just want everything in terms of one fraction. That's just a little bit easier to work with. So one thing that we can recognize is that every quantity can be written, and that's in the denominator, can be written as a fraction itself, as x over 1. And if we have division by a fraction, it becomes multiplication, right? So here, this quantity right here, this is the same thing as saying 1 over 3 plus x minus 1 over 3. This whole thing divided by x over 1, right? So here we can say this same quantity times the reciprocal of x over 1, which is 1 over x. So now that we have it in that form, let's try and combine these two fractions together and see if we can get any cancellations there. So we see that we have two factors in the denominator of 3 plus x and 3. If that is true, then to combine these two fractions, we would need a factor of 3 plus x in this fraction, one way to put that factor in is to just multiply the denominator by 3 plus x here. Oop. But if I do that in the denominator, then I also need to do it in the numerator. So I'll take 3 plus x and multiply it there too. Over here, I'm missing a factor of 3. So I multiply the denominator by 3 and the numerator by 3. So when I do that, I also have this minus sign here, right? When I do that, then both have a factor of 3 and a factor of 3 plus x. So I can write it as the two terms in the numerator sharing the common denominator of 3 times 3 plus x. And in the numerator, remember that I have this minus sign in between my two fractions, so that gets carried up. And I get 3 minus the quantity of 3 plus x. And we carry forward that 1 over x. So, bringing that down, right, we distribute the negative sign to both terms here. I get 3 minus x. So, our positive 3 and negative 3 cancel out, becoming 0. I'm left with a negative x on the top. And in the denominator, I am left with a 3 plus x, and an x once I distribute this into this grouping. This 1 over x into this grouping. So the x factor cancels out with this x factor, leaving a negative 1 in the numerator. So I'm left with negative 1 over 3 times 3 plus x. There's nothing stopping me from doing direct substitution at this point into that. So I have negative 1 over 3 times 3 plus 0, which is equal to negative 1/9. And that is number 59. And we will pick back up on number 61.